Right, this will be going over your basic drug calculations for your drug math. So when we're talking about drug calculations, you have to realize that we are doing, we do have to do math. You have to be able to convert drug orders into units so that you know how much drug will be administered, because most of our orders are going to be a set drug weight, which is measured in grams, kilograms, micrograms, or milligrams. And our syringes, the methods that we are going to give the drugs, are going to be measured in milliliters. So we've got to be able to convert from that drug of weight to a volume amount so we can draw the proper amount and give it. All of our drug dosages are going to be in units. They're using the metric system, which is your base 10. It's commonly used in your science and your medicine. Now you've got different prefixes that you're going to use for multiples and submultiples, and we'll talk about those in just a moment. There's only a handful of them that you need to be concerned with at this point in time, though. Important things: your whole numbers are going to be placed to the left of the decimal. Your fractions or portions are going to be to the right of the decimal. Whenever you see a slash symbol, like a forward slash, it's going to be a per. So 25 milligrams per kilogram would mean that you would give 25 milligrams of drug for every kilogram that that patient weighs. So if that patient weighed 10 kilograms, you would be giving 250 milligrams. It's also important, make sure that you always use a leading zero when less than a whole number. For instance, here it's 0.4 milligrams. If that decimal were to leave, then it could change what you have. If that zero was not there and that decimal point went away, then it might look like 4 milligrams. And there's a substantial difference between 0.4 milligrams and 4 milligrams. Additionally, never use a zero with a whole number. So 25 grams is your dose for dextrose, D50, but if you put a 0.0 on the end of there and you lose your decimal, then 250 grams. Once again, that's a substantial difference from just your 25 grams, so it's always very important. Now your common prefixes, these are going in order to your base unit down to smaller. Gram is going to be mass, liter is going to be volume, and meter is going to be in length. We don't use a whole lot of length-based in EMS, except for with pediatrics, and usually going to have a PD sleeve or Braslo tape or something of that nature that uses the length-based. But for the most part, in drug math, we're going to be dealing with grams and liters or milliliters. Now, there are several different prefixes here. If you might remember from elementary school, King Henry died drinking chocolate milk. That's the way I always remembered all of them. But we're not going to use hecta, or we're not going to use deca, we're not going to use deci, we're not really going to use centi. So mainly what we need to be concerned with is kilo, milli, and micro. So a kilo is 1,000 more than the base unit. So a kilogram would be 1,000 grams. Your milligram would be 1/1000th gram, so it would be 0.001. When you're looking at decimal places, remember that to the left is your whole number, to the right, that first space is going to be your is going to be your tenths place. Your second spot's going to be the hundredths, and then the third spot's going to be your thousandths. So that's why it's equal to 0.001 grams. Now your micrograms is going to be 1/1,000,000th of a gram. So that's going to be 3 additional zeros in front of that 1 to make 1/1,000,000th. Now, when we are going back and forth between the kilograms to grams, milligrams, or micrograms, if we're going from a larger unit to a smaller unit, we're going to multiply by 1,000. So this is the exact same thing as moving that decimal point 3 spots to the right. So if you're going, your example here, 1.2 milligrams. If we want to go to micrograms, we're going to the right because we're going to a smaller number. So we are going to move that decimal space from between the 1 and 2. We'll go over 1, 2, 3 spots, fill in those spots with zeros, and so you get 1,200 micrograms. Now to change from a smaller unit to a larger unit, we're going to divide by 1,000. So this is the same thing as moving that decimal point 3 spots to the left. So if you want to go 250 milligrams to grams, you would divide by 1,000 or move that decimal spot. So the decimal point would be at the end of the 250, so it'd go 1 to the left, be between the 5 and the 0, another one to the left between the 2 and the 5, and then one more to make the third spot, so it ended up being 0.25 grams. Now, converting pounds to kilograms. So you can do one of 2 ways. You can long divide and move your decimals, move your 2.2 would convert to 22, and you would add a decimal and move a spot on your 180, or the easiest easiest way that I found that's fast, it doesn't usually require a calculator, take their weight and divide it in half. So 180 divided by 2 would be 90. And then figure 10% of the number you just got. So 10% of 90. For every 10 you take away 1, so that would be 10% of 90 would be 9. And subtract that from your 90. So 90 minus 9 is 81 kilograms. Now let's try a few more using that method. So let's look at 200. Half of 200 is 100. 10% of 100 is 10. So we're going to take away 10. So 100 minus 10 is going to be 90. Next one, 146. 146 divided by 2 gives you 73. 10% of 73 is 7.3. So we're going to subtract that from 73, so we get 65.7, which would round to 66 kilograms. 320 divided by 2 gives us 160. 10% of 160 is 16. So 160 minus 16 gives us 144 kilograms. This will get you right there at it within a kilogram every single time. Drugs by body weight. Remember that slash means per. So a drug order that says give fentanyl 0.5 micrograms per kilogram means that for every kilogram that patient weighs, you've got to give them 0.5 micrograms. So they weigh 180 pounds. So first thing we have to do is convert to kilograms, right? So we can get our actual drug order. So 180 divided by 2 is 90. 90 minus 10%, which is 9, is 81. So then we're going to take our kilograms and multiply it times our drug amount. So 81 kilograms times 0.5 micrograms per kilogram. And that will give us 40.5 micrograms. Now your next one, diphenhydramine. We want to give 1 milligram per kilogram. The patient weighs 25 pounds. So we're going to convert 25 to kilograms. So 25 divided by 2 is going to give us 12.5. 10% of 12.5 is 1.2. So subtract that, that'll give us like 11.3 roughly, and then that would round to 11 kilograms. And then we multiply that times our order, which is 1 milligram per kilogram. So 11 kilograms times 1 milligram is going to be 11 milligrams. Now when we're doing drug dosage calculations, all right, we have to be able to find the concentration. So we have to be able to know how much drug per milliliter in the packaging, or per liter, or per whatever. All right, you have to be able to figure out. So what you do is you take the drug weight, which is going to be your gram, milligram, etc., and we're going to divide that by the volume of the solution that drug is in. So for example, your epinephrine 1 to 10,000 comes packaged 1 milligram per 10 milliliters of fluid. Alright, so we would take drug weight, which is 1 milligram, and divide that by the drug volume in the container, which would be 10 milliliters. So when 1 divided by 10 gives us 0.1 milligrams per milliliter. So that's our base concentration. Let's try another one, diphenhydramine or Benadryl. It comes packaged 50 milligrams in 2 milliliters. So we take our drug weight, which is 50 milligrams, and divide that by the volume in that container, and that is 2 milliliters. So 50 divided by 2, and that gives us 25 milligrams per 1 milliliter of drug. Now when we're looking at a volume of drug to give, we have to be able to sort out exactly how much volume we're going to be given to deliver the amount of drug that we want. So there's a couple of different ways you can do this. Some of them are very easy. You can look if they're nice even numbers that are easily divisible. You can usually figure it up in your head fairly easily using ratio and proportion. But for the ones that are not easily divisible, it's important to have a formula so that you know how to figure out how much drug you're going to be able to give. So for this formula, we're going to use desired dose times volume divided by your dosage on hand. This will always work. Okay, your desired dose is how much drug you're giving. This is your ordered drug. Alright, this is going to be units, grams, milliequivalents, milligrams, micrograms, grams, whatever the drug amount is. Now, your dosage on hand is how much drug is in the container that you're taking the drug from. Okay, also usually is going to be expressed in milligrams, milliequivalents, grams, units, whatever. Volume of drug is the amount of fluid in the container that contains the drug. Okay, so this is usually going to be milliliters, and it's going to be found on that label. And we'll look at a few labels here in a few minutes. So let's try this one. Epinephrine, we want to give epinephrine 1 to 1,000 0.3 milligrams IM. So we're giving this drug intramuscularly. So we're going to look at our package. It says it comes packaged in an ampule containing 1 milligram per 1 milliliter. So we're going to find our desired dose, which is 0.3 milligrams. We're going to multiply that times our volume in the container, which is 1 milliliter, divided by our volume in, or excuse me, divided by our drug in that container, which is 1 milligram. So divide out 0.3 times 1 gives you 0.3. Divided by 1 gives you 0.3. So you would give 0.3 milliliters to deliver through 0.3 milligrams of drug. And let's try another one. This is a kind of a multi-step issue here, but let's say we're going to give lidocaine to a patient. We want to give 1.5 milligrams per kilogram of lidocaine IV push. And the patient weighs 220 pounds, and the lidocaine is packaged 100 milligrams in 10 milliliters. So the first step is convert pounds to kilograms. So 220 pounds divided by 2 is 110. 10% of 110 is 11, so 110 minus 11 would give you 99 kilograms. So now we're going to have to figure out our actual desired dose. Because remember, our formula is desired dose times volume divided by the drug in that volume. Well, we've got our volume and our drug in that volume, but we don't have our desired dose yet because we can't put in 1.5 milligrams per kilogram. It doesn't work. So we're going to take our kilograms, 99 kilograms, and we're going to multiply that times our 1.5 milligrams to get our total drug dosages. So 99 times 1.5 gives you 148.5. So we're going to plug that into our formula. 148.5 times 10 divided by 100, and that's going to give us 14.85 milliliters, which we would round to 14.9 milliliters. Let's try some more. Phenergan is ordered 12.5 milligrams. Phenergan is ordered 12.5 milligrams. It is supplied 25 milligrams per 2 milliliters. So we're going to plug into our formula. Desired dose is 12.5. Our volume in the container is 2 milliliters. Our drug in that volume is 25 milligrams. So 12.5 times 2 divided by 25 gives us 1 milliliter. Now you can also look at this ratio and proportion. If there's 25 milligrams and 2 milliliters, well 12.5 is half of 25, so you would need to give half of 2, which would be 1. Either way, this one's fairly easy, but you need to know the formula for the more complicated ones that don't easily divide out. Let's look at amiodarone. Amiodarone is ordered 150 milligrams IV push over 10 minutes. Now in this particular situation, right this instant, does that 10 minutes matter? No, because we're just trying to find out how many milliliters we'll be given. You've got to be able to look at the formula or the problems and figure out what exactly you need to solve it. So desired dose is going to be 150 milligrams. Your volume volume in the container is going to be 10 milliliters, and the drug in that container is going to be 200 milligrams. So 150 milligrams times your volume, which is 10, which will give you 1,500, divided by your drug, which is 200, will give you 7.5 milliliters. So let's look at cyanocobalamin, or B12, a little bit easier to say. Our order is going to be 600 micrograms, and so we have to look at this label here. Now you might notice there in the middle you've got 1 milligram per milliliter, and then below that you've also got 1,000 micrograms per milliliter. Those are the same thing. It's just measured in different units, but 1 milligram is equal to 1,000 micrograms. So you have two choices. You can either use the 1,000 micrograms in your calculations, or you can convert 600 micrograms to milligrams. I like using micrograms because it's a little easier for me. Also note, there at the top you see a 10 milliliter multiple dose vial. So that's important to note that there's a total of 10 milliliters in this container. So if there's 10 milligrams or 10 milliliters in this container and there's a 1 milligram per milliliter, that means you have 10 milligrams in 10 milliliters. Now you can use that dosage, the total drug and total volume, or you can use the base concentration, 1 milligram per milliliter. Either one is perfectly fine, but you have to use the same either way. You can't use one and one of the other. You have to use both total or base. So 600 micrograms times your volume, which would be 1 milliliter, because I'm using the base concentration, divided by the 1,000 micrograms in that 1 milliliter. And so you get 600 divided by 1,000, which gives you 0.6 milliliters. Narcan. Alright, so our desired dose here is 1 milligram. You look on your container, you see that you have 2 milligrams per 2 milliliters. So 1 milligram times your volume, which is 2 milliliters, divided by your drug in that volume, which is 2 milligrams, gives you 2 over 2, which is equal to 1 milliliter. For your thiamine, you want to give 100 milligrams IN. This is one of those you can kind of easily look at it. Now, if you look at the base concentration, 100 milligrams per milliliter. So right off, you know you need to give 1 milliliter. But let's say that wasn't there. 100 is half of 200. So what's half of 2? 1. So you would give 1 milliliter. Now, epinephrine, this one is a weight-based, so this will be a pediatric, and it's 0.01 milligrams per kilogram, and the patient weighs 48 pounds. So the first thing we have to do is look at the weight and convert that to pounds. So 48 divided by 2 gives you 24. 10% of 24 is 2.4. So that would give you 21.6, which you would round to 22 kilograms. Now we're going to take that 22 kilograms and multiply that times your 0.01 milligrams per kilogram. And that's going to give you 0.22 milligrams. So that's our desired dose. Now we plug in 0.22 milliliters times your volume, which is 1, divided by your drug in that volume, which is 1, and that gives you 0.22 milliliters. Zofran or Ondansetron, this we want to give 2 milligrams IV push. So we're going to take this 2 milligrams times your volume in that container, which is 2 milliliters, divided by your total drug in that container, which is 4 milligrams. So 2 times 2 is 4, divided by 4 gives you 1. So you would give 1 milliliter to deliver this amount of drug. Albuterol sulfate, we want to give 2.5 milligrams. Well, this comes packaged 2.5 milligrams and 3 milliliters, so we're going to give the full 3 milliliters to give that much drug. Diphenhydramine, we want to give 1 milligram per kilogram. The patient weighs 54 pounds. So we had to figure out pounds to kilograms. So we take our pounds, 54 divided by 2 is 27. 10% of 27 is 2.7. So 27 minus 2.7 gives us 24.3, which would round to 24 kilograms. So then we're going to plug in 24 times 1 is going to be 24 milligrams, because remember it's 1 milligram per kilogram. So we want to give 24 milligrams. Now we have everything we need to plug into the formula. So 24 milligrams times your 1 milliliter divided by your drug in that milliliter, which is 50 milligrams. So 24 divided by 50 gives you 0.48 milliliters to deliver 24 milligrams of drug. Next, so we want to give 10 milligrams PO, which is by mouth, and we've got 1 milligram per milliliter. So if there's 10 milligrams there and there's 1 milligram per milliliter, we want to give 10 milliliters. Now, when we are doing drip rate calculations, you have to consider the time and the drip factor. Remember, when you're talking about the drip factors, that's that number on the packaging, your 10 drop set, your 15 drop set, 20 drop set, 60 drop set. All that number is how many drops it takes to make 1 milliliter. So your macro are going to be bigger drops, 10, 15, 20, and your micro are going to be your 60 drop sets, and those take 60 drops to make your milliliter, so they're smaller drops. So you've got a formula for this as well, and it's going to be the volume to administer times your drops per milliliter, your factor set, your drop factor, divided by your times in minute. So, example here, you're ordered to give 200 milliliters of normal saline per hour, and the IV set is 10 drops per milliliter. So you would do volume to give, which is 200, times your drip factor, which is 10, divided by your time in minutes, which is 60. So that would give you 33 drops per minute. Let's try 2 more. Your protocols call for a 20 milliliter per kilogram fluid bolus. Your patient weighs 180 pounds and your transport time is 3 hours. What drip rate will you use, say, set with a 10 drop per milliliter set? So the first thing we got to do is figure out our volume to give, right? So our volume to give, we're going to take their pounds to kilograms, because we're giving 20 milliliters per kilogram. So 180 divided by 2 gives you 90. 10% of 90 is 9. So 90 minus 9 is 81 kilograms. So now we're going to take 81 times 20, And if you set it up properly, 81 times 2 is 162. Bring down your 0, so you get 1620, 1,620. We're going to plug that into our formula. So 1620s are mLs times your 10 drops per milliliter. Your milliliter is going to cancel there. Divided by your time in minutes. So 3 hours in minutes is going to be 180 minutes. So you get 1620 times 10, which is 16,200, divided by 180, and that gives you 90 drops per minute. Your next one. A physician orders 500 milliliters lactated ringers to be infused over 2 hours. You have a 10-drop IV tubing set. How many drops per minute will you give? So volume to give is going to be 500. So we plug that in, times our drip factor, which is going to be 10. And we're going to divide that by 2 hours worth of minutes, which is 120. So 500 times 10 divided by 120 gives you 41.6, which will round to 42 drops per minute. Whenever you're dealing with drops, you're always going to round to a whole number because you can't give a fraction of a drop. So you're going to have to round it up or down, just using your standard rules of rounding.